Hi, I'm Rich with insideHPC, and we're here at SC13 in Denver, Colorado, and we're here at the CEA booth. Welcome to the show, by the way. You're having a good show?
Oh, yeah, sure.
You are. So let's start at the beginning. Who is CEA and what's your mission?
So CEA is a large research company, a government-owned company from France. And we are doing research in many fields ranging from energy, such as nuclear reactors, to life science, material science, astrophysics, and many other fields such as nanotechnologies. So it's a fairly large research company, and we have many workers in. For us, HPC is a big issue.
So HPC is a big part of what you do, isn't it?
Yeah, sure. Because in some cases, especially for astrophysics, for example, we are not able to get hold on what is inside a star. So we have to rely on numerical simulation to understand the underlying physics, and it's exactly the same at the nanode scale, at the atomic level, when you want to produce new material with special properties, or even to understand what unexpected properties we notice in nature are, and then the only option is to simulate that.
Yeah, these things are very hard to observe in nature, do experiments.
Absolutely.
Right?
Absolutely.
Okay. So we're here today to talk a little bit about Allinea. You guys have worked very closely with them, haven't you?
As we just said, HPC is important for us, and what we've seen in the past years is simulations are getting bigger and bigger and bigger. So we're using petaflop machines, and you have one. You have the machines illustrated on the board behind us. But at petascale, it's very important to have the proper tools to help the code developers and the users to debug and to analyze what's going on in the code. And without the help of Allinea, we will be completely blind. And it will be a major problem for us to get that scale.
Yeah, because these machines might have hundreds of thousands of cores that you have to use, right?
The Curie machine has close to 90,000 cores, and when you have such a big simulation running a full machine, if something goes wrong, you can't rely on just a print. You have to have the proper tools, and that's what we've been doing for years now in close collaboration with Allinea to make sure that their software is able to cope with our simulation on our largest machines. And it's been a very successful collaboration.
So let's talk about the future. I mean, where do you see things going for CEA?
So the future is very clear to us. We will be at the exascale level in 2020-ish, probably 2021. At that scale, there's a very limited number of codes as of today able to run on those machines. So we will need tools to make sure that the existing codes are able to use the next generation of machine, which are absolutely necessary for our programs. So
because software is very important at that level.
Software will be probably the most difficult part of the exascale, because you have to express parallelism, and parallelism is not an easy thing to get a hold on. Because of the physics, but the way mathematics has been transformed into line of code. In the past, people were mainly thinking sequential. Now we have to think in terms of massive parallelism. And without tools, basically we're dead.